Hello, this is Jason with LMGI. Today we're going to take a look at a part that would be normally made out of a sheet type material where this top face, actually if I use Part Painter and so this face and this face would be the flat face of the sheet good that this is going to be manufactured from. It does have bevels on the edges so we'd like to cut this out with probably a CNC router and then be able to just kind of twist it because it's a flexible foam type core material, and then it will fit into the shape. So what is the shape of that flat piece of material? So there's a few ways that you could do this. You could possibly create a number of sections through here, and it can be kind of tedious depending on how many sections you create. But let's take a look at using the blank body. I'm going to move this to synchronous because there are some benefits to that, and one of the things you might want to do is position the part so it's a little more convenient. So I'm going to go ahead and make this rigid, and I'm just going to pick all the faces and accept. And the reason I did that was so that I could then do a coplanar. So for example, I may want this face, and I'll right click to accept. I may want that aligned with the XY plane, for example. And then you could use your steering wheel to move that. I'm going to grab the entire design body, drop the steering wheel on the face. I'm going to hold shift and click the disc to get it flipped, and then if I hold shift while I click the origin, this will allow me to position it precisely, and then I can move it up to a particular location. Not necessarily required for what we're going to do, but good to know. Sometimes it's helpful to reposition. So we're going to use our surfacing bar, and there is a blank surface. There's also if you go into the flatten mode, you'll have blank body, but that is a little bit of a limitation in that there's usually only one flat per model, and you have to do it. I want to do it twice. I think you'll see. I'm going to go ahead and choose blank surface, and there are some settings in here. You can experiment with the strain hardening component. You probably just want to make sure you use the same value on both faces, as you'll see. I'm going to just leave the defaults. Click this top face. Now the origin, I want this to be consistent, so I'm going to take this and I'm going to drop it. I'm going to try to slide along my base coordinate system and then just do preview and finish. And then we're going to run the command again, and I'm going to pick the bottom face, and I'm going to put this guy here. I'll hold my control key down, click the little knob, and flip that 180. So it's kind of important that they both be pointing in the same direction, so that you'll see that the thickness should be really close to what the original thickness was, as long as I keep that directional arrow in the same. Now I'm going to hide my design body just to make it a little easier, and if we look at the I guess the back view, you see things are a little bit out of alignment, which, this is flexible material, so you got to kind of expect something different to happen on a broad face versus a smaller face. But again, the synchronous modeling is really very useful here. If I come down and first I'm just going to kind of lay it on the top face and use my little trick where you hold the shift key down, because I want the steering wheel to be oriented a certain way. Now you probably would want to maybe draw a sketch, bring that sketch in on the end and make sure it's aligned the same, or you could actually maybe turn your design body back on and kind of move it up to this lower face so that you could make sure the faces are relative to each other at that start point. You know, very easy to do with the synchronous modeling. So if I needed to shift this down a little bit like that, I could do that. And then to do a rotate, I'm going to again hold shift and click this knob, click to here. And if you poke at the steering wheel enough, you'll find you can come up right there. That wasn't really the orientation I wanted, so I'm going to click the down, right. So it looks pretty good. So see, my mouse pointer is kind of in the directional vector that I want. So that's the way that you can rotate that top face. At any rate, you kind of want to get them relative to each other, and you maybe have to copy a sketch onto each end to help position them. But at this point, we're ready to turn this into a solid, and I'm going to go and just make a loft. It's probably the easiest way. I'm going to add body, so we have a separate design body. And if it's a simple shape like this, you can probably just go right to the loft command and use the face method and grab this face and right click to accept, and then this face and right click to accept and right click to preview, and there's my loft. So there it is. It's flat, just like the sheet goods would be. Now the ends are not square, so again, that's where your synchronous modeling could come in. You could use your face relates and make things perpendicular. Let's see if I can see how that goes. We'll make this. So that's not a flat face. So we could probably just tip that with a steering wheel, or we could do a replace face on it. Something like that. If you wanted to make that pretty close. Again, this is flexible, somewhat easily deformable material. And I could do the same with the other end if I wanted to. So that looks pretty good. Now, if it's a more complex shape, you may end up using some of your surfacing tools and do a blue surf and kind of build each face independently. Sometimes you try to do too complex of a loft and it can be a little tricky, but blue surf would let you build up individual faces, and then you would stitch all those surfaces together and make a solid body out of it. So now we could send this over to the a router that cuts sheet material and make our parts, and we'd be pretty confident that they'll be able to be formed into the 3D shape. So there you go.